Hi, everybody. I'm Paul McCollum. This is session one in Dev Up, a multi-part series where Adam Olshansky and I go over development concepts for people that are learning or thinking about getting into Salesforce development. I'm Paul McCollum. I am a technical architect at Accenture. I've been programming since, probably the last 40 years now. I started in 1978. I've written Hello World in just about every language that's out there, but still consider myself an intermediate and learning programmer. Adam?
Thanks, Paul. So my name is Adam Olshansky. I'm a Salesforce engineer at Google. I have not been developing quite as long, but I've been in the Salesforce space since 2014. Salesforce MVP, Salesforce Platform Developer 2 certified, and I enjoy talking Salesforce and specifically Salesforce development. So thrilled to be here.
Yeah, thanks for joining me, Adam. Adam is one of the people that I looked up to and started learning from whenever I came over into the Salesforce ecosystem. So I'm excited to be partnering with him for this session where we'll hopefully be teaching and sharing some of the stuff that slowed us down as we came into the Salesforce ecosystem and learned. So this is me attempting to cover and help you through the hurdles that I hit, and then have Adam, of course, guide and lead us on all the things that he knows and is really good at. Excuse me. All right, so this first session is objects and records. Objects is a fairly basic concept inside of Salesforce. If you've worked with Excel, you know rows and columns. They're basically, objects are Salesforce's implementation of a database table, records being a row in the table, fields and so forth being the column. It's the core of building any application inside of Salesforce, is setting up relationships between different logical entities and different objects.
Yeah, I think our next bullet point has it there as well. I always like thinking of Salesforce as like a really fancy spreadsheet. That's, I think, the easiest way for people to kind of grasp it, right? We have all the different tabs. These are different objects. We have all of our columns. These are different fields. And then, like you mentioned, all the rows are the individual records. And, I think one of the nice things about Salesforce is it provides all this automation on top of things. So it's not just me entering stuff manually into a spreadsheet, hoping I entered it properly, hoping I didn't forget to enter something, having to manually remember, all right, well, this field is like this, so now I need to go email this person, or this field changed here, so now I need to go make a manual update here. All the automation built into Salesforce is really what I think is the best part. But definitely thinking about it as a spreadsheet, I think, is the easiest way to explain it to anybody, at least talking about objects and fields.
That's a great point. And one of the things that we're really trying to do in this session is we're going to be casually discussing stuff that has become the kind of the core basic vocabulary of development in Salesforce. You start to think about Salesforce in a different way when you're working with it as a developer. So as we go through these concepts, if we're batting terms back and forth or speaking in something about something that you're not really familiar with, that's definitely a sign to go pick that up, find some trails, and hey, I don't know what objects are. Hey, I don't understand why objects look like a spreadsheet. So find some tutorials, reach out to us if there's something you don't get, and we can point you to it. But just watch for these terms. The stuff that it feels like we're joking around and familiar with is probably something you need to be at that level to be able to run around in dev and code all day.
Yeah, and that's a good point. Real quick before we move on, just bringing up all the different terms, right? Salesforce has different terms for things, and they might make sense to us working with Salesforce all the time, but in your place of work, you're probably going to interact with Salesforce admins, Salesforce developers, non-Salesforce developers, business people, and everyone kind of has a different notion of what an object is. So when I talk to non-Salesforce developers, I probably won't say, what object is it? I'll say, what table is it? Because to them, they're thinking of it as a relational database, which is really what Salesforce is under the hood. It's a relational database, objects that know about each other, can connect with each other, and things like that. And so when I'm talking to a developer, I'll ask them about the tables, and I'll ask them about the columns. And I won't get into the nuances of API name versus label, because they're not in Salesforce. They don't know what that is. So yeah, definitely, and we may even use these terms interchangeably as well. And terms have, different languages have different terms for things also. Different systems have different terms for things, but Yeah, again, like you said, though, if something's ever not clicking, do some more research on it, and we'll try to use all the terms we know for something. And for the different audiences you'll interact with, it may help to be aware of them. Someone's asking you about a table, and you're going, "Table? What are you talking about? This is an object." It helps to have to bridge some of that disconnect sometimes.
Yeah, I think we have it in a slide coming up, but just a perfect conversational segue. I was hitting my head against a wall trying to learn Salesforce whenever I kept wanting my user account reset. And I kept asking, can you reset my account? It's like, okay, which company do you work for? No, my account, my user account, where my password is. Oh, your user. No, yeah, my account. And the word account has a different meaning inside of Salesforce than it does in a lot of other languages where it means like your user ID or user account. So watch for terms like that. If they seem like they're being used, ask questions early. I didn't ask early enough. I just kept I knew what an account was, and nobody was going to tell me any different. And it slowed me down and caused me a lot of headache that I could have gotten past if I said, hey, are we talking about the same thing? What is an account? And asking what is an account in front of Salesforce people was hard. Was not my happiest day. And then, okay, got it, finally. So yeah, watch for those. If it seems like we're talking crazy, ask questions, raise your hand, post notes, post a question online, Ohana Slack, answers.salesforce.com. Don't be afraid. There's always somebody starting or always somebody who is just one day ahead of you and can give you that answer. All right, so the core, or at least, and this to me is really the corner, the joint of every intersection of every bringing together of concept for Apex development is IDs. The database, and I really should have pulled up a different table and shown some different IDs and IDs. IDs are the social security numbers of every piece of data. They're the home address, they're the IP address of everything. So start it for a computer, it's a home location, a way to find something, because computers don't speak English, they speak locations and data. And so getting things down to, there may be 4 Pauls and 5 Adams, but each Paul and each Adam in a system will have a unique identifier, an ID, that's a GUID. GUID is a abbreviation for globally unique identifier. Salesforce IDs fall within roughly the same patterns for that, but it's a long stream of letters and numbers that mean something that Salesforce uses as a unique key to connect information.
And if you are coming from a non-Salesforce system, you can think of this as like the primary key in this object or table or for this record. It's what, like Paul said, is going to identify the record. It's going to be unique across your Salesforce org. In Salesforce, there's going to be a 15-digit version that is case insensitive, I believe, and 18 version that is case sensitive, or did I mix that up?
Yeah, I think you're right. 15% case sensitive, 18 that's case sensitive,
Okay.
I think is right. I think we have that on the next slide.
Oh, okay.
Yeah, we've got a key breakdown of of how GUIDs are made up. Adam, do you have a page that has a URL you want to pop in? And I'm going to open the account object and pull some.
So I can share my screen real quick. And yeah, so Paul said, these IDs are going to help kind of identify records in Salesforce. So if I navigate to the account tab over here, I'm looking for an account. I can pull up all the accounts in my new dev org I just created. And you can do this in your org as well for any object. When you click into a record, you can see in my URL bar here, I'm going to URL of Salesforce, some Salesforce URL. It's going to mention the account object, and it's going to mention this 18-digit record ID here. And what I can do with this record ID is and I think we'll talk about this in the next slide as well. I'll notice the first 3 letters indicate what object it is. So 001 in all orgs is going to be account. And then I have the full ID here as well. And what I can do if I know a record ID and I'll never want to navigate to that in Salesforce, I can just copy the ID. I can be anywhere in a Salesforce org, and I can just manipulate the URL, take out everything after force.com, put in the ID, and it's always going to take me to that record page because, again, like Paul said, it's going to be a unique identifier for that record. So this is always going to take me to the University of Arizona record.
Yeah, so it's so universal, it's so unique that all you have to do is put that ID in the URL. You don't have to tell it what type of object it is. As long as you're in the right org, you'll be taken directly to the location. I think there's even part of it that's the org key. So if this were mailed out, somebody at Salesforce could reverse engineer what org this was an object from. Not something you'll be able to make much use of, but just interesting tidbit for us engineers.
Yeah, and even if I don't know the object, or I guess wrong on the object, I can think this is a contact maybe. And even then it'll still redirect me to the correct account record because it's looking at the ID, and you see even change the URL as well. But it knows it's an account, it knows what record it is, and it's going to be able to take me there. And so that's a URL trick if you ever want to get directly to the account record, to any record actually in Salesforce if you know the ID. If you don't know the ID, but you know the ID prefix and just want to navigate to that home, I could click on the accounts tab, or I can use this 3-digit prefix 001. Again, take everything out after force.com, put in just 001. And again, that is going to take me to that same account homepage as well. Again, just a little trick if case maybe the tab isn't part of your application, or you're in an application that doesn't have that tab, you just want to navigate to the tab quickly. If you know the 3-digit identifier, put it in the URL and be able to take you there as well.
Yeah, that was a humbling experience when I first met somebody who had memorized a decent number of the prefixes. And I was looking at a piece of data and I was pretty sure it was a contact and it was a 001. And oh no, that's an account. It's 001. I'm like, what? Wait, what? You can read the GUIDs? I stopped talking after that and just listened as Megan just completely educated me.
Sometimes it's helpful also, like you mentioned your point, when somebody was asking to reset their user account, and you know, different people have different terms, you don't necessarily know what record they're talking about. If you tell them, hey, can you just send me the ID of the record you're talking about, or can you share your screen? You could see, or take a screenshot even, you can see exactly what record they're looking at or record they need to get to based on the ID. So that can be helpful. Somebody tells me they're trying to access a contact record and they send me an account ID. And it's like, well, are you trying to access a contact? You're trying to access to an account. So asking more questions and looking at the IDs can definitely be very helpful in troubleshooting as well.
Yeah, preview for one of our upcoming sessions. So you've got up there, you have put the Salesforce ID up in the address bar. And that is acting as a parameter inside of a URL. And so as a developer, understanding the URLs and the URL structure will be super important. I think that's session 7, which browsers and requests, where hopefully we'll talk through how the browser works and some of the other tricks, but be paying attention to what's going on in the URL, because there is a lot of developer important activities going on up there that you'll be able to see API names and GUIDs up there that may be masks in the people facing and the user facing UI, but you'll need to know them as a developer. I've got another screen up. I have queried the object table behind the scenes and I have pulled up. Let me go ahead and re-query. Let me add name. So to the backend system, this is an export or a query on accounts, pulling back a couple of different columns, with its relationship to the user who last modified it, who the owner of the account is, and then a reference ID. This is the ID for the account itself, and the master record ID. These are all technically, if they had data, would be GUIDs. These GUIDs are references to other records, and the GUIDs are the Salesforce IDs are the pointers to other records and other tables that this record is related to. So this is a back-end view. This is a developer conceptual view. This is how the data is actually structured in the database. So as a developer, this is how you'll want to start thinking of the data, and that everything follows breadcrumbs from one ID to another ID to another field to another ID to another field. And that's how you'll be able to pull and make relationships and manipulate data to create solutions.
Yeah, and one thing before you actually minimize that, Paul, one other thing I wanted to call out was if you're familiar with looking at Salesforce records, if you look at a record, it'll tell you, hey, here's the last modified by, and here's the owner of the record, and it'll show you names of people that you can then click into. I think it is important to note that while it shows you the name of a user, because there's actually a lookup relationship, and this is the case for all lookup and master detail relationships in Salesforce, it's really an ID behind the scenes. And the Salesforce UI is just kind of turning that ID into something more readable. Because if you tell me the owner ID is 005, 0B, something or other, that's not going to mean anything to a human. But because Salesforce is a computer, essentially, it stores that as an ID in the background. And so it's important to remember any lookup, even though you might see some text there, to see what record that relationship is to, it is an ID in the background, and that'll be important when we're working with it in code.
Yep, another slide that we have coming up that makes more sense to talk about now is the IDs are the unfriendly names for every records, and then the name, the text characters, the person's first name and last name, those are the friendly version. That's a concept we'll be picking up on or pointing out a lot of cases, that the backend name usually has to be very unique and type safe. You have to be able to address it uniquely, but the front end name could be, just Paul, just Adam, where there could be lots, but we could all share the same first name, but we'd all be identified uniquely by some backend key. So this is not everybody will need to know what is going on, and we minimize. So on decoding IDs, this is really, it can help. You'd be surprised when it will help you. But it's just good to know, to be able to come back and look for a reference of, if you are ever dealing with an unknown object, an unknown link, you get an email with an ID key in it that you don't know, that you can go and reverse engineer where every ID came from, and make sure you figure out which sandbox it came from. So anyway, and I took this decode from Fisher Prey article, so giving them credit there. Anything else from this, Adam, that you want to talk about?
Yeah, Daniel, the Fisher Prey has a great website. He used to be a Salesforce MVP, and now he's an engineer, I believe, with the Apex team, working inside Salesforce. So he's done a lot of good articles on this. But yeah, he's cataloged pretty much all of these standard out of the box prefix keys, and so it's interesting to go on there and look. And I think he keeps it up to date whenever they have new releases and new kind of behind the scenes objects. But yes, you can see every object, even the random ones you would never have thought of, have one. List view has one, user role has one, group has one. And again, these can be very useful in determining, just by looking at an ID, what object is coming from. And we'll talk about custom objects in a little bit, but there is a method to the madness here. But
and actually, that's one other important thing that a lot of people miss, even pro developers. This is not an encrypted string. It may look random, but it's an encoded but not encrypted progression. So it's a fancy way of saying there's a 1, 2, 3, 4 behind the scenes that somebody could guess. So if you give somebody this URL, they might be able to guess other URLs from it, or what was before it or what was after. So don't think that this is encoded. It is not encrypted in any ways. It is just complex to the point that it's hard to understand for people, but it is not hidden, and you can derive some information from it. So be aware.
And that's another good point, and another reminder to make sure your external and guest user security is locked down, because if somebody can guess or has some IDs to your org, they're going to be able to access URLs. They're going to be able to query data pretty easily if you don't have all that locked down, and that's going to obviously have big implications for your company. So
we'll have a whole session on security. So a little preview. All right. Well, back to the big picture stuff. Adam, you want to?
Sure. Yeah. So this kind of, when I was starting the Salesforce, tripped me up. I kept, and I guess, to your point, also people are asking about a user account. Well, a user and account mean very, very different things in Salesforce. And for me, when I was starting, it was always lead and opportunity, right? I know they're both have something to do with sales. And then we talk about, lead conversions and things like that. But these objects, I feel like, are pretty universal. You will most likely touch one or more of them in pretty much anything you do with Salesforce, just because they are so crucial. And for the very basic use cases out of the box, right? Sales will use leads to kind of gather information from prospective customers, and then leads can be converted into accounts, contacts, and opportunities. Accounts being kind of companies, contacts being individual people at those companies, and then opportunities being a kind of sales opportunity. I want to make a sale to this company, and maybe I have some contacts at the company that I'm working with. And so those are all important to know. As you mentioned, user records represent people with kind of licenses that can log into Salesforce, who may have passwords, may have some single sign-on they're using to sign in with. The quicker you can implement something that gets rid of passwords, I think the better. So not have to deal with password logins. My current org doesn't use passwords for anybody, and it's wonderful. Nobody ever asked me to reset their password anymore. Login, again, just different things to different people, but when we're talking about logging into the org, that's someone putting their credentials in to sign into the org and get whatever access you've given them. Case being kind of a support related object. If someone's having a service issue, they're going to potentially be creating a case. Maybe that's coming in via email, maybe that's coming in via the web, maybe that's coming in via some process in your org where a case can be created. And then campaigns most often are used with marketing, where you're running kind of some sort of sales campaign or marketing campaign to generate new business. Maybe you're going to a trade show, maybe you're running advertising, things like that. But a lot of these objects have kind of special behavior that they work in conjunction with each other. I think campaigns you can add, what is it? I keep changing it. I think now it's contact, lead, and opportunity, maybe. I think there's some combination of 2 or 3 of them you can put under campaigns. So you can say, okay, this campaign directly led me to these opportunities and these new contacts and things like that.
And you did something in your head there that and it's I struggle with ways to provide words for this, and I call it primitives. So the relationships of this one parent thing has this type of relationship to these other things, and it's one to many here, it's one to one here, and it's many to many there. And that particular shape and set of functionality is kind of a primitive relationship model that if you strip the labels from it, and you can see those shapes and those relationships, that's what makes a really good developer. Is you can come in and reuse the relationship, but abuse the names a little bit. And you can write code really fast if you can just shift perspective of, yeah, when I mean lead, I mean surgery operating room, because inside of the surgery operating room, I'm dealing with users like surgeons, and I'm dealing with tools like leads, and I'm dealing with stitches. And my analogy falls down very quickly, but some of the big power and the ability to develop solutions quickly is to understand the existing primitive models of data and relationships, and being able to hijack them for your purposes, and be able to overload them with different things. And I was trying to explain to somebody why you would need different orgs for something. I was like, well, it's if your primitive models for all the basic objects don't line up the same between 2 orgs, you don't want to use them together. You'll have too many exceptions. But if you can shape what you're doing into an existing cookie cutter primitive pattern, most of that work is already done, and you just go in and change some labels on a page. And you can use all the existing data structures. So.
Yeah, and that's a good point. It's definitely good to know about how these relationships talk to each other, because there is a lot you can reuse without having to reinvent the wheel. I remember somebody was asking me once how they could, if I could build some functionality to turn leads into opportunities, and their face lit up when I said, "Oh, actually, I'm already done. Salesforce can do that for you." So, understanding some of these kind of relationships out of the box, I think, are and understanding the differences between the different objects are definitely helpful,
Yeah.
especially for a lot of use cases.
Yeah, Nana Gregg made me realize that one of the best capabilities a developer can have is knowing all the admin tools that are already out there so that you don't spend time reinventing the wheel. And you will never look as bad as a developer when an admin comes in and checks a box on setup that replaces 6 months of your development effort.
Yeah.
So yeah.
I generally recommend when people are starting with Salesforce, even if they want to be Salesforce developers, I think that's great, but I definitely recommend understanding the admin side of things first, because like you said, that is kind of going to govern what you actually have to build and what you know that you don't have to build or can build quicker with a checkbox or with a basic formula, or something that's going to be a lot quicker and more sustainable than 6 months of work reinventing the wheel. Security model also is important to understand when you're coding in Salesforce as well. So definitely recommend going that route.
All right, standard versus custom objects. So whenever what you're doing doesn't fit into an existing model, or the existing model is really already well defined and it has a lot of complexity built to it that you don't want to make any changes to it, that's when you'd go building your own custom objects and setting up your own custom relationships. The biggest difference to be able to see the back end of a custom object, custom objects are so core to Salesforce that their friendly name and their machine name are usually the same thing, and they don't carry the characteristic _ C after everything that I believe the C stands for custom, but I don't have the history there. So accounts is such as a basic object, and the computer, the behind the scenes API name for accounts is account. If I made a new custom object and I called it account, the system would automatically add _ C to it, and it would be different and unique from the regular account without the underscore. Now, obviously, you wouldn't want to do something like that, but that does happen. They behave all the same way as standard objects, but they don't have a lot of, sometimes they won't have the same functionality pre-built around them that a sales process and lead and opportunity. There's some workflow and some other functionality that doesn't automatically exist on a custom object when you create it. Even if you intend it to act like a sales lead, it won't have that functionality out of the box, because that's custom functions that are built around those custom or standard objects. Sorry, standard functions around standard objects.
Yeah, somebody once tried to talk me into building them a custom account object, and I fought with every fiber of my being to avoid that, because again, whenever you can take advantage of standard Salesforce functionality, accounts have a bunch of cool things built in, like the ability to convert from leads, the already pre-built account contact relationship, the already pre-built, contacts to multiple accounts functionality. And so to reinvent all that usually isn't worth it. I'm sure there are some use cases where it is valid, and with the pre-built functionality, there are also some limitations. For example, the address field on account is built in a certain way that doesn't fit everybody's use cases, and maybe you need it. And I've had orgs where I have custom address fields on the account that I use in place of the standard address fields. But yeah, whenever possible, I agree to take advantage of the standard functionality. I was curious if you knew or had any idea, or guesses maybe, what the reason was why Salesforce does add the _ C, because I don't actually know what I understand, to tell the difference between standard and custom objects, but I'm guessing there's a technical reason why they chose to do that as well.
I have not run across that story. I know that, so C would be a designation. Underscores are fairly regularly used to take the place of spaces. So I'm guessing that when that was built up, and I'll just historically imagine here, that double underscore wasn't something that people did very often, that there might be a lot of underscores. And so to set this apart and to keep it so that they could search for, that made it distinct from where everybody was using underscores in the place of spaces, and added that code on there. I could not tell you a good story. We need to go find somebody. I'm sure we can find somebody that has that level of history that could go tell us that. That'd be a neat, interesting tidbit, but not for today. You don't need to know why that happened to start deving, but it's there. You'll see it a lot. Anytime you see it, it's custom. It means that you're dealing with something that's been custom created, and it works for fields and relationships as well. And speaking of relationships and developer and API, we've already really discussed the difference. Do you want to refine the definition of label versus API name?
Sure, yeah. So a label is basically what users see in the Salesforce UI. So if I have an object called, let's say, the classic example is always the job application, job search kind of built application for Salesforce. So I might have an object called job application. My tab is going to say job space application. My record is going to say, new job application. And the API name behind the scenes is going to be job underscore application underscore C. If I want to say, okay, I don't want it called job application anymore in the UI, I want it called job submission. I can change the object name to job submission. My tab name will change. My UI will change. The API name is still probably going to be job underscore application underscore C. And as someone who's coding or even working with formulas, it's the API name that identifies the object. It's kind of like the ID for the object, right? You can make the label pretty and make it say whatever you want to end users. Yeah, change it altogether. And I have encountered that as well, where there's a history and the label name and the API name, nothing to do with each other, or at least aren't very well related. But it's the API name that's going to come into play when we're talking about code.
Yep, could change it to requisition instead of job application, but still have the same API name behind the scenes. All your code will still work. The front end label is the only thing. And so we talked about primitives. So, and I guess we need to talk about types of fields before we talk about relationships. Types of fields. So we're talking about data types, right? The difference between a number and a string of characters and a date. All of those have different meanings and different ways that they're sorted and different spaces that they take up in memory. So you'll want to familiarize yourself. Let's see. Oh, we've got fields and data types on the next screen. So what were we? Maybe we can talk about that in the next slide.
Yeah, I think we can get into different types. I think here we just kind of wanted to maybe float the idea that there are going to be different types of data you're going to want to capture. Some of them are going to be, like you mentioned, primitives like text and numbers and things like that, and some of them are going to be relationship based, like we kind of touched on a little bit before as well, where you can connect objects to each other. And I think this is really, to me, part of the magic of Salesforce, that it is more than just a spreadsheet where you have different rows and different tabs, but rather the objects all kind of coexist together. And that's obviously what kind of makes Salesforce a relational database. And these relationships are all going to represent the foreign keys. If you're speaking to other developers, might be the term they're more familiar with, but Salesforce generally, they're going to be referred to as relationship fields. And again, like we talked about, they're going to show up in the UI with the kind of friendlier name. Behind the scenes, it's going to be another ID.
Yep. And these are not the only type of relationships that are out there in the development world, but Salesforce has picked the most key and made it very simple for you to set up one-to-many, many-to-many. All of these things are loosely related, but still independent, or they are directly related. And if the parent record doesn't exist, then the child doesn't either, or anything that happens to the parent record automatically happens to the child record. So that's your master detail record. So understanding, we probably don't need to go in too deep here, but just understand what each of those relationships means. Those are your primary ways of setting up relationships. So you need to start thinking, when you're thinking relationships, trying to making sure you can shoehorn it into one or multiple of these existing main relationship types. You can have relationships to external systems. There are external IDs that'll kind of bookmark where data is in external systems as well. I know we wanted to cover that. And with some of these, there are capabilities. You have to be aware you can actually point things in a circle. So if you're doing any kind of tree traversal, realize that some of these have some failings that can lead you to problems that you have to maintain. So if you're trying to find the 6th level parent of something and you've accidentally created a circular relationship where a parent points to a child or grandchild, you can run into that. So be aware of how these are set up and understand some of the pitfalls that you have to plan for around with them.
Yeah, and there are some limitations Salesforce gives as well. Like I think you can't make a standard object be the detail in a master detail.
You can't make a what?
A standard object. There's some limitation regarding standard objects and master detail relationships.
Oh, okay. I don't know that one. There's why some detail. You can. There's a setting on master detail that you can't. In theory, a child record, a detail record inside of a master detail can't be reparented. You can't say take this line item and attach it to a different parent. But sometime over the past couple of years, there's a checkbox now that you can allow reparenting of detail records. So, I think I got that on an exam once, and I was curious whether or not the fact that no, you can, but it's recent. It was like within the 6 months of my exam that there was a question on there that had changed. They'd added the ability to reparent detail records, but that's one of the key features of master detail relationships is that you can't. But there's a checkbox that says that you can. So understand that those both are out there. So.
And then junction, I think we touched on, but like you mentioned, those are for many-to-many relationships. So the example again, that I think if I have a job that I want to post, I might want to post a single job. I might have an object for job, and I might have an object for job site. So I might have a job that I want to post on many job sites. And on each job site, I want to have many jobs posted there. So I need some sort of relationship where I can have many jobs on one job site, and I can have one job posted to many different sites. And so in that case, we'd have a junction object, which would basically have master detail relationships to 2 different objects and represent the junction of where those 2 objects to come together. So it could be something like job posting.
Yeah, I think I've used that with applicant and job, or sorry, with user and job, and the junction object is an application. So a job can have many applications, and a user can have multiple applications to multiple jobs, and that's that many-to-many junction object.
Yeah, another great use case for that as well. One other thing to note here, I guess 2 other things to note here, the italicized text about spaces. So this is the other thing I tend to bring up when talking about API names. Code and spaces don't play well together. You may be kind of subconsciously familiar with this. If you've ever seen a URL you click on, end up putting a %20 in its URL, that's the URL trying to process a space. It looks very ugly, and it's not very readable. So to avoid all that, Salesforce just auto converts the spaces in your labels to underscores, and then underscores are much easier to read than spaces.
Yeah, spaces separate completely separate things. You can't have a label that refers to my first name and last name are my label. They're not 2 different arguments. So somewhere in computer speak, you would have to replace that space with a connector like %20 or a non-breaking space, or however you want to do it, to show the system that this is one label and not the start of another argument, or you'd put quotes around it to make sure. So you'll have to be aware that the computer, the backend system, the compiler that's working with it can interpret spaces and different characters differently. So space is a big one.
Yeah, and then the last thing on here, external IDs that you mentioned also. So this is a good use case where, in a lot of environments, Salesforce isn't the only system. It's one of many systems that make up kind of our landscape. And so oftentimes we have records in Salesforce that we also have another version of in another system, and we want them to be able to talk to each other. And Salesforce is giving every record an ID, a unique identifier. External other systems, non-Salesforce systems, probably are as well. They have their own IDs. And so I might be communicating with the developer on this other system, and they have a whole list of records with their own IDs, and they need to somehow have those records talk to the Salesforce records. And so I can make a field in Salesforce called external ID, and that will allow me to kind of identify that record based on an ID from another system. And so it'll let me query based on that record, it'll let me update based on, or query based on that ID, update based on that ID. And so it doesn't always have to be the Salesforce ID. And I think there are options to specify that as unique. You can also leave that as non-unique. Again, kind of depending on your other system requirements. To me, always making that unique would make the most sense, assuming the external system has also made it unique, but a lot of different use cases out there. So always good to have the option, I think, but definitely come in handy a lot of times as well, especially when working with non-Salesforce developers and trying to figure out what record they're talking about.
Yeah, unique, case sensitive, and space or system consumption aware, I think are some recurring fields that you should be looking for. Anything plain text or looks easily readable is probably not going to work or probably have some extra representation inside of programming and development. All right. Fields and data types.
Yeah, so yeah, I was going to say, like we mentioned, a lot of different field types you can make, and some of these are going to equate directly to what we also see in code. So if I can create a date field on an object, I can use the date class in code to reference it. Other things like a checkbox, that's in code, it's just going to be a Boolean. So again, depending on who you're talking to, sometimes I'll say checkbox, sometimes I'll say Boolean. Again, things like a pick list, which is, some people will say a drop down because they're not going to know what a pick list is. Whereas to me, I'm talking about pick lists all the time if I'm working in Salesforce. But if I'm talking to a non-Salesforce developer, I might just say it's a string, because at the end of the day, it's going to get converted down to text. And pick list actually has kind of been one of my pet peeves when we make formulas. We always have to use the is pick val function, because to me, it's all text, right? So why are you telling me this text needs a special method where this other text does not? So I definitely get caught up on that pretty much every time I make a formula involving a pick list field. That gets called out.
Yeah, that's one of the things that tells you that is pick val is probably referencing something that has an actual GUID value under the scene, behind the scenes, and it's protecting you from having to look that up and find that uniquely.
I never thought about that. That would make sense, I guess.
No. Yeah, and our little subtext up there, and that's this will break your brain the first time you do it, the first time you run into it, and the first time you have a bug related to it. I've got up there in quotes, the capital letter O in quotes, and then a zero in quotes, and then zero by itself. So O is the letter O in capital. It looks very similar to a zero, but it is not. O is probably 15th letter of the alphabet. Yeah. And zero is the number representing no number. But in the ASCII table of characters, I think it probably in there, most computer systems, if I put a zero in my name, it would be or at the start of my name, it would be considered the 27th letter of the alphabet. If you put zeros right at the end of Z. So if you were alphabetizing Adam and me and Zero Paul by first name, Adam would go first and Zero Paul would go last. And if there was somebody named Peter would come after Adam, but before Zero Paul, because Zero is dead last. Now, that's how you would alphabetize the character zero, but Paul is not a number. Zero is a number. So without quotes, we're talking about the number. We're talking about numerals, implementations, decimal points. If there are, is a different type of number. Numbers without decimal points are integers. Which can go negative or positive, but they're still whole numbers. So there's a mathematics concept that bleeds into characters and strings that you need to understand when you're counting or doing values or trying to add up or sort by numerical values. You're dealing with numbers that won't be in quotes. If you put a number in quotes, you're turning it into a string. which means it's going to alphabetize it as it's related to Z and Q. It's not related to 1 and 2, except that those are next in the order. So you have to start building you have to get kind of good at math and understanding a string can start with 0, but a number starting with 0 is the same thing as it starting without 0. It won't be unique. 00001 is just 1, unless there's a decimal point in front of it, in which case it's entirely different. If there's any letter in it, it really stops being a number. So you're dealing with all this, and it matters when you're starting to sort, arrange, compare, and work together, which you will do. My first name plus my last name plus a space in the middle is how you display somebody's name on a page. And so that a plus sign in that case will be, well, anyway, it won't add the numerical values of my name together and come up with 7,455,000. It will deal with them as strings and tie them into N. So that's a rough understanding of what the difference is and how you'll need to know how to work with them in code. So data types, all that leads up to that. Variables, when you're creating a variable to hold string or a variable to hold number, you'll need to create them uniquely. So each variable will only hold one type of data. And this is important so that if you accidentally try and store another type of data in a variable that's intended to hold one type of data, which will cause errors, you'll hit the error early on and not just in processing when people are using your tool. So it's safety, and it's also part of memory management. You want to use the smallest variable. If I know that I'm going to be dealing with numbers between 1 and 4 in other languages, I would create a very small number. I think number is the smallest number field that we have inside of front end Salesforce. So Adam, you want to help me out here? I'm kind of running at the end of my
yeah.
I'm ready to talk about casting. I'm ready to talk about casting.
I was trying to not jump into that just yet either. Like Paul mentioned, it's important to understand the differences, especially when creating variables. And it's also important to understand what the data types are when you're creating the fields. I've definitely had scenarios where I go look at an object, I see a value, 1, 2, 3, 4 in a field, and I assume it's a number. And so I go process it as an integer in my code. And then Salesforce tells me, sorry, you cannot convert string to integer. And I'm like, what are you talking about? There's a number right here, but they made it a string field. And so it's, being able to recognize how the different fields equate to values in Apex is definitely important. Things like checkboxes being Booleans, things like currency being a decimal, email being a string, geolocation. I think geolocation might even have its own data type in Apex now, and you can get the latitude and the longitude from it.
Yeah, there's a structure in there. I think address also has an innate structure as well. Most times, is that a data type?
Address, I think they break down because on account, they have the address field, but behind the scenes, it's billing city, billing country, billing state, billing postal code, and then on contact, it's mailing city, mailing state, shipping city, shipping state. So it definitely has
compound variable.
Yeah, compound field is what they call it. But yeah, phone I think breaks down to text. Percent breaks down to decimal. Numbers and integer. Pick list is text. Multi-select pick list is also text. It's just concatenated with a semicolon. And then of course text is a string as well. Sure. But yeah, I definitely have run into issues like that. And so, and even things like, I think even actually number fields might even always just be decimals rather than integers because they always have some number of decimals, even if that number is 0. And so I think by default, the number fields generally get processed as decimal values in Apex as well.
Yeah, now these are fields in variables. Apex, and I always have to go look because these are fields in Salesforce. They're data types in Salesforce objects, but they're not the same as the types of variables that is possible to create in Apex. I think you can create an integer in Salesforce and have it not be a decimal or a float. So anyway, there's data types inside of Salesforce proper that you can put on an object, which number is kind of multifaceted and holds both of those places. It can be positive and negative, and it can have decimal, or it can be whole or not, or no decimal places. But it just matters what kind of data you put into it. I think it's open to a wide range. It's probably just the extent of the decimals, the float space, or double space, whatever they call it.
And then, of course, since we talked so much about it, ID is also its own data type in Apex, but you can also use string in pretty much all instances where you see ID.
Yep, it is. I think text. Yeah. And then casting is something you need to get familiar with, and it ends up being very important, and people stumble over it a lot. Whenever you need the number 4 to show up inside of a string, or if you need to convert a number into a string, the concept is called casting. You're trying to convert it, and a lot of systems implicitly know that the number 4, which is a binary representation of zeros and ones, and the character 4, which is a completely different binary representation of zeros and ones, it has an internal translation table for those values. You just it won't do it automatically. If you try and assign a number 4 to a string variable, some systems will fail and not be able to do it, but you might have to wrap it in a function that casts it into a different data type. And you're saying the variable that's holding 4 to string, and store that to the var, which is implemented as a string. And so those are different casting. Sometimes there's implicit casting, which casting will happen by itself behind the scenes in different languages. And those can be scary, because if you don't know when you're doing it on purpose, it keeps you from realizing when you do it accidentally. So a big concept when you're working between multiple data types that you have to get used to casting, or some kind of translation functions that move data into different data types.
Yeah, and I would just add on to that, because at a score, casting really is kind of trying to turn one data type into another data type. And so there are some ways that we can kind of explicitly do that. We could say like string.value of, give me the string version of this number. In other cases, we don't necessarily, or Apex doesn't necessarily know what data type something is. And so we have to tell it, hey, you have some value. I'm going to tell you that it's an integer. So try to turn it into an integer and give it to me as an integer. And this is also common and I think we have a different presentation on this later when we start working with external systems and things like that. But I might get some structure from an external system, and I need to turn it into something that Apex can understand. So I'm going to tell it, hey, I have this data. I'm telling you it's going to look like this. So turn that into an instance of this data type. And it's easier to work with from there. So like Paul said, definitely great to understand and very, very useful. I find myself casting in many different circumstances, but at its core, it's just when I either don't know what type, or Apex doesn't know rather what type of data something is, and I have to tell it, or I want to explicitly turn one data type into another data type, where the representation of that data type, like we have up above, where I might want to turn the number 0 into the text 0, or vice versa.
Yeah, there's a fun case. So Booleans are a data type, which are represented as true, false. So the friendly name for a Boolean, or the friendly display of a Boolean, which is behind the scenes technically a 0 or 1, but friendly, it's true or false, or it's on or off, or it's yes or no, or it's represented unchecked or unchecked. And I've written programs where I've wanted to count up the number of checked boxes. So true, 0, or 1. If you add 1 to 1, you get 1. It's in binary math, but you have to convert a Boolean to a number to be able to add it together and get up a sum total that's a number, because otherwise the only number that's possible in 0 or 1 in binary is 0 or 1. There's no such thing as 2 in the binary data type, in the Boolean data type. So the important thing on fun stuff you run into on casting. It's a 1, yeah, but it's a different 1 than the one that you're working with. That's a 1. Well, or it's 0. When yeah, but no, that's really off. You can't add off to 2. Yeah, and it's so yeah, your brain will break until you get it, but these are concepts you really need to go after and understand innately.
It's like the old joke, there are 10 types of people who understand binary, those who understand it and those who don't.
Yeah, exactly. There are only 10 types of people in the world. Those who understand binary and those who don't. Yep, nerd humor for sure. All right, so as we've talked about data collections, that is a term for a piece of data, a variable that contains more than one element. Geolocation, we talked about address, those are compound variables that contain, a full name is kind of a collection that's made up of first name and last name. Collections are more of the classic programming structures or arrays. They have different names inside of Salesforce. The different names have different features. We have lists, maps, set, and arrays. Working with those, knowing how to loop over them, doing loops and operating with wrapper objects, a big thing that you need to know. You need to be very fluent in maps, sets, loops, and working with wrappers to process any kind of data inside of Salesforce. I think we're cheating and taking the easy way out by pointing to a presentation off of Apex Hours called Mastering Apex Collections. That came out when we were building this slide deck, and it was too easy to just hop over and point to that of just go learn this here.
Yeah, another shout out for Apex Hours. Amit does a great job of bringing guest speakers. I've been on there a few times. But yeah, there's a whole collection up on YouTube of various Apex topics and various Salesforce topics, not just Apex. I think he gets into some front end development as well. But yeah, great compilation of everything involving the 3 primary collections in Apex: list, set, and map. So good to know them all as well. Guess we can give a high level overview. Maybe also list is just maybe basically a bunch of a single data type. So I could have a list of strings, a list of integers, a list of accounts. And the thing with the list is they're all ordered with a given address. So I can say, okay, what is the first thing in my list? What is the second thing in my list? How many things are in my list? And I can get answers to those questions. Set is pretty much the same as a list, with the exception that there's no ordering and there are no duplicates. So if I have a list of strings and I tried to add Adam to it 10 times, the set's going to tell me there's one item in the set and it's Adam, right? So it can't tell me where in the set it is, it just tells me that it's there somewhere. So I think of sets as like just a giant bag of stuff, and I can reach into the bag and pull something out, but you don't necessarily know where it is at any given time. And then a map is just basically you have one data type mapped to another data type. So the most common is usually ID or string to some structure. So I can have an account ID mapped to an account, and I can access the account information based on the ID. And so it allows me to take what are called keys and map them to values. And so I can access the values based on my IDs. I can also map a key to a list of something. So I can have a list of accounts mapped to a certain string name. So definitely very useful when programming as well.
Yeah, list maps and set are all usually 2-dimensional key value pair structures. Sets are unindexed, maps are single indexed, and you can have complex data inside of the value. So there's some other ways to do that, but I think list, maps, and sets really only support that 3rd dimension. Arrays can be fairly infinitely dimensional. So when you start dealing with drilling into and finding stuff in data structures, and where if you do any really hardcore processing, I start getting into arrays because you're able to index and count into elements in multiple dimensions, whereas list, maps, and sets are usually fairly get me the element at this, or does this element exist? Yes or no, not get me the 3rd row of the 2nd order of the 4th relationship, and what's the name in that field. And so you can get complex in all of them. Understanding how to set push and pull into sets speak different languages with them, the different, you can actually talk to a list as if it's an array. You can use array indexing on list, or you can use, the next iterator and stuff like the standard list code terminology. So some of them are interchangeable, but it's good to understand, have that picture in your head, like Adam was saying, of what the data is inside of them, and then the language that's used in each one to iterate over or to access data within them can be very different. Again, I'm sure that's all covered hopefully here. I would learn that this is where most of your work is going to be done when you're writing big programs. I would say that's usually where I'm doing my stuff. Fair, Adam?
Yeah, I was going to say, people might also be familiar with this concept if they're very into flow. You can create collections and flows as well. You can also have flow loops, the loop over the collection, and that's really all a loop is doing. It's taking the collection and iterating over it one item at a time, looking at it, validating it, processing it, updating it, accounting for it, essentially. And so loops are very useful, and you'll see them in conjunction with collections almost every time.
Yep.
Both for loops and I don't know about you, I don't use while loops very often. They were while some condition is true, let me do some processing, but.
Yep, that's the trouble with loops is that you can go infinite, and if you don't, with for loops, you're kind of required to set a an exit condition and make sure that you're hitting it, and that's the primary function of a for loop, or at least back in college programming, that was how they explained it. But I think Salesforce tends to like it and lean on it as the do while structure is very useful, and they have some internal protections against infinite loops that help make it to where that more friendly. Most of the time you are going to be looping over a given object. And in the order that you've queried it from the database, there's no reason to add to type that in every time. So do while kind of saves you that time of, you're looping over this object. Yes, you probably want to do it one at a time, right? Like, yeah, not every other number, or until only keep looping over the same thing until something happens. It's, very specific reasons that you'd want to use for loops at this point, but it is still my habit to do everything as an array and to use a for loop on it every time. So.
Makes sense. The only other thing I'd add for wrapper objects, you touched on it briefly, but again, it's called a wrapper because you're basically wrapping up something as some data type. So you can, I like to think of it as inventing your own data types. So like we have an account object, but maybe I'm getting data from an external system and it's not an account. It's not really anything. It's just its own structure. So I can invent my own data type, wrap up this data I'm getting as that data type, and now I have something I can work with. So maybe I'm wrapping it up as kind of an account. Maybe it has an account property to it, and I want to add some additional properties to the account that aren't necessarily fields on the account. I can create an account wrapper that has an account, has an extra Boolean that I don't necessarily need a field in Salesforce for because I'm only using it in code. So a lot of use cases for wrappers, and often you see it going hand in hand with casting. I'm going to cast some structure to some wrapper object structure that I invented.
Yeah, wrappers are something I wished I'd learned a lot earlier. They solved a lot of problems. Salesforce Apex really wants you to work in object variables, and those object variables take the exact structure of the object, and adding extra fields or extra data that's related to that inside of your code. You can keep a map and a list and try and relate them together and then start playing between the two of those, or you can pull in your extra data from your join or what have you into a wrapper and have it in one object, and it makes it much easier to work with. I still don't speak fluent wrapper, and I should go learn and do more of that. All right.
Yeah, and like that as well, great examples online. If you do get stuck, I also get stuck almost every time.
Who does?
Oh no, I just say in general. No, I don't have a specific resource, but in general.
I'll bet there's an Apex hours on it.
Most likely.
Other code constructs to be fluent in, since we get to the end of our list. Okay, so we've already talked about a little bit, and this is, so there's probably 5 or 6, I would say, different code layers inside of the Salesforce ecosystem, and they are variations. Most of them are C-type, which means that they resemble each other, but they're not always the same. And you can come into things that when you're working in formulas, it works this way, but when you're working in Apex, a symbol can mean something completely different. Or in LWC JavaScript, it'll have a completely different meaning. I think, what were you correcting me on earlier? Not equals. Yes, that right there on this slide. There's another language that I work in that I've gotten used to NEQ, meaning what this exclamation point equals sign. And hacker speak, I always call that bang equals. So the exclamation point is a bang, and the equal sign. And when you're reading code, so this would be paren, be careful, be care with, I forgot careful, bang equals, quote, not equal, quote, thesis. So being able to say parentheses out loud and knowing it's an open paren or closed paren. But anyways, there's some other way you'll start looking at at English characters and language different, because they are implemented and used and mean different things when you're writing code. So in string and math, the and symbol usually means connect these 2 strings together, but don't do anything to the contents, just hook them up like train cars. Plus usually means add the 2 values together and come up with something that didn't, 3 plus 4 turns into 7. 3 and 4 turns into 34. So if you looked at them as strings versus as that, but a lot of times plus can mean concatenate and turn strings into 34. So each of these operators may, depending on the layer of code that you're working in, may have different languages. So be ready as you're writing multiple layers of code in Salesforce to go get your bearings and find that and can mean different things depending on where you're at and what you're doing and which piece of code. And even here, this means string concatenate. This means math add. This means and when you're comparing 2 conditions together, if you want to say if something is this and this other thing is that, you would use the double and symbol. And then this double pipe symbol means or. And that can change. What is the other one? Well, I don't know if they do binary XORs and XANDs in Salesforce anyway, but there's some other terminology.
I don't think so. Yeah, yeah. I remember back to college logic classes. We definitely went into all that good stuff. But yeah, I don't think we have XOR in Salesforce.
Yeah, at least different meanings, different symbols, but just be wary that there may be variations on meanings, and that you need to orient yourself when you're writing different types of code. The equal symbol in SOCL may be different than the equal symbol in Apex. The not equal symbol in SOCL is definitely different than the not equal symbol in Apex. So this is generally, I think the double square brackets together is SOCL, but I think that also works in Apex.
Double angle brackets, I think.
Yeah, square. Yeah,
the like greater than less than.
Yeah. All right, I'm out of breath. Will you take logic, sir?
Yeah, so yeah, like Paul mentioned, different symbols mean different things, even within Salesforce. We were just looking earlier, the single ampersand, you can concatenate things in a formula, but a single ampersand is going to give you an error message in Apex. So another reminder, always build your stuff in sandboxes first and make sure to test it out before going to production. The double ampersand in code is very similar if you're familiar with the and function in a formula. The double, called a pipe, the straight lines there means or in code, similar to the or function in formulas. But you can also actually use the double ampersand and the double pipe in formulas. And to me, I think it reads easier if I say this thing and this thing versus and this thing comma this thing. To me, that's harder to read. But again, different people have different preferences, and it's the same with code. Different people have different coding styles. Things like that. So yeah, definitely a lot of logic you'll see in code. The exclamation point, also referred to as the bang, is going to be not. So you'll see not equals to quite a bit. You'll see exclamation point Boolean value to represent not that. So if you're looking at a checkbox field and you want to see if it's false, instead of saying if this is false, this equals false, I can just say if exclamation point field name. And that also means if this is not true. So with that, just like in formulas also, we have if statements in code, we have else statements in code. We can also have multiple conditions with an else if statement. And that's just basically checking logic one condition at a time. If some condition is true, we want to go into that part of the code. And if not, we can continue executing until we reach our final fallback else condition.
Yep.
And then
I think the one thing I wanted to be careful with, my typo on the side is now mocking me, not equals. So remember when you're trying to do nots and not equals, that be very specific. You really want to be if equals this or equals that. Be specific about what you want it to not equal. Not equals means everything except for this is a valid answer. You may be dealing with numbers. If you get strawberry, well, that not equals 4. But you probably wanted to find out that you were passing strawberry to something that you wanted 1, 2, 3, or 4 as your answer. Not equals is a very generic, and just remember that that represents infinity minus the case that you presented right there. And infinity is a pretty big thing to pass through and not catch. So I've seen a lot of patterns where people have hurt themselves and not realized what kind of inputs would be coming through the system that they weren't filtering out. Because they thought you would only ever get 1, 2, 3, or 4, and they were getting 85 and the letter Q, and they hadn't caught those, and everything was working fine because that doesn't equal 4, and they had problems up there. So I would say be specific with those. That's almost like logical typing, typing, versus just kind of open-ended not equals logic. There's a couple of different ways to do if else. And I should have put in here an example of the ternary expressions of if then else, where then is the question mark and whatever, or else is the question mark, then is a colon. There are different ways to write that in shorthand. I don't like that. I like my code to be readable. Like basically you can read the statements, and I have very long variable names so that you can, if you say the code out loud, it kind of speaks to what's going on. But there are other ways to do that, but be very good at if then else. Be good at nesting if else, if else, else, if else within itself to catch different things and start and have an opinion on how to structure that and how that displays so you can keep track of that. A lot of people have problems with disentangling their own code because they don't build good structuring and aren't very fluent with nested if-else structures. Switch case is a way to get around really ugly if-else, and then having nested, well, if it's not this, then is it this? And if it's not one of those, then do this third thing. And if it's not that third thing, then try this fourth thing. The switch case structure, and is it a win structure we found in Apex? You have some sample code on switch case, right?
Yeah, we can show that.
Switch is really good for just testing if the value of a certain variable is equal to this, that, the other, this last thing. And if it's none of those, then do this final thing. Do you want to share that code snippet?
Sure. Share that. One other thing I want to note before we share the code is we didn't put it on the slide, but the equal sign also definitely tripped me up a lot when I first started coding. Ooh. If you have a single equal sign, that means like set it equal to. So I could say like, integer x equals 5. The
You're
double
signing
equal
a value.
sign, assignment. The double equal sign though is comparing equality. So that'll be something like if x equals 5 is asking a question, is x equal to 5? So instead of assigning, it's doing some equality or comparison for equality. So it definitely tripped me up quite a bit when I first started out.
Yeah, one of the interesting ways people got around that, there was an original pattern where, to make sure you were using it the right way, you would put the thing that the literal on the left. So you would say 5 equal to X. And if you were assigning 5 to X, you would say X equals 5. And there used to be different operators. And this worked great, except there was one language that allowed you to use 5 as a variable. So people were able to assign the character X to be what 5's value was. So you never think it's going to happen. Somebody will do it when you accidentally don't type the extra equal sign and you meant to, and you end up assigning the value to a new value versus comparing a value. Yeah, it's very important to understand those 1 equal and 2 equal. Yeah, great call out.
Yeah, all right. So I'm going to show a bunch of code here, and we can walk through it all step by step. Just something to keep in mind whenever you walk through code you haven't seen before. Don't try to take it in all at once. Always go line by line. Makes it a lot easier to understand. All right, so we'll take a look at a bunch of the things we just talked about here. So I have a trigger on my account object called account subpar trigger, because it's using all these if else ifs instead of the switch statement that we're going to see in a second. If you haven't seen triggers before, they're very similar to basically any other automation you build in Salesforce, workflow, process flow. You just have what it is. It's a trigger. Just like any other automation, you give it a name. Just like any other automation, you tell it what object it's on. And just like any other automation, you tell it when it should run, right? We want it to run when it's inserting records, updating records, deleting records, and then before the records are saved, after the records are saved, and we can pick and choose from these events when we want this trigger to fire.
Yeah, classes and triggers. So classes are code without reason. Triggers are code with a reason. Triggers run on a very specific event, and other things would call classes, or you'd call them from them and make the use of them, but they don't have the innate being tied to an event function that a trigger does.
Yeah, so classes can be called either from a trigger, from another class, or we can also schedule them to run at a specific time. But like Paul mentioned, if you want a trigger to run, it has to be on some event on some object. So in our case, we have it on account. And here I have an if statement, a couple if statements here. So we have, just like in a formula, the word if, and then we can ask the trigger questions about itself. So we could say, hey, trigger, are you running? Because this is after some records are being saved. And so in our case, if it's after, we're going to come into this code block in lines 5 to 20. If it's not, if it's a before trigger, we're going to come into lines 20 to 27. This is going to be our before block. So we see our else statement here. Within our after block, we see another if statement. We say, okay, hey, we know you're running after save. Are you running because records are being inserted? Then we have our logic operator or because records are being updated. And then, like Paul mentioned, we have this kind of weird ternary operator. And this is essentially the same as an if statement, but saying, hey, I want to have a variable of type string called operation, and I want to set it equal to a value depending on this first thing. So again, I'm asking the question, are you an insert trigger? So I'm asking a question, so I have a question mark, right? Is this true? Is this an insert trigger? If it is, this is going to be my value. So operation is going to have a value of insert. And then I have essentially my else, which is going to be a colon. And then I have my else. So operation is going to get the value of insert for an insert trigger, and it's going to get the value of update for an update trigger in this scenario. Again, not necessarily as easy to read, but also fewer lines of code than writing an if statement for it. So pros and cons, again, kind of depending on your style. And then here we see
that's doing some. There's some almost casting there. So you're creating a variable called operation that is of type string, and you are assigning it to it the results of an equality statement that is the Boolean value, the true false value of triggers. The trigger structures is insert field, and you're saying if that is true, the question mark means then you're assigning it the string of insert, and the colon is saying if it's not true, then sign it the string of update. So there's a lot of logic that's very elegantly put and very few characters in that one string there. And after a while, you'll read that just like, oh yeah, no, that's exactly what that says. Of course, I didn't need an explanation, but this ternary version of if then else, I still have to slow down and read it. It's not my primary way of expressing if then else logic, but it's very elegant and clean.
Yeah, agreed. Definitely. Definitely takes a second to get your bearings around, but once you start seeing it again and again, it becomes a little more familiar. But yeah, same here. I have to do a stop. Okay, wait. First one is true. Second one is not true. Yeah. And then okay. So then now we see we're going to call a class from our trigger, and we're going to see a few different ways to call this class. But for now, we have an account handler class, and we have a method in the handler called handle trigger.
We didn't talk about dot notation. We went over that. We went over structures, but that dot is meaning that it's a sub element inside of that greater variable. So that larger structure has a key value pair built into it, and the name of the key is insert or is update. Sorry for interrupting you. I'm just seeing things as we're going.
Oh no, yeah, that's a great call out actually. Let me show another quick example. I can have an account A, new account, right, and I can do something like string account name equals a.name. So we talked about, again, these are the API names of account and account name, but I'm going to again use dot notation to reference a field on an object. I'm going to use dot notation to reference a parameter on some value. So in my case, I can use it to reference a method in a class. I can use it to reference a parameter on this trigger structure. So definitely very, very useful and very, very common in pretty much all types of code in Salesforce. All right, so with that in mind, this dot tells us, hey, we're calling a sub part of our parent here. So I have a class called account handler, and I'm calling a method in account handler called handle trigger. And handle trigger is going to have a couple things that it's going to ask for. And so we're going to give it what are called parameters. So we're going to give it 3 parameters. We're going to give it trigger.new, which are going to be all of the new values of the records that cause my trigger to fire. So think about I'm uploading 100 counts in data loader. Maybe I'm updating them all, right? And I have the old values of what the accounts were before I changed them, and I have the new values of what the accounts are after I've changed them. So all of the new values are going to be in trigger.new. All of the old values are going to be in trigger.old. And then I'm also passing this operation type. So that's going to be either my after insert or my after update, basically asking the trigger, why exactly are you firing? So that's going to be the operation type there. And if I go take a look at this account handler class, again, we see similar to the trigger, we have a word telling us what type of code it is. This is a class. We have the name of the class, account handler. And we see our method down here in line 16, handle trigger. And if you remember, we passed 3 things to it. We passed the new accounts, the new values of all our accounts, the old values of all of our accounts, and the operation that caused the trigger to fire. And so in our method signature here, we have to basically account for all that. So our method signature is going to tell us, hey, for me to run, you need to give me one list of accounts. You need to give me a second list of accounts. And then you need to give me some trigger operation. And I'm going to create temporary names, temporary variables to be able to reference those things. So you're giving me a list of accounts, and I'm going to call the first list of accounts you give me my new records. I'm going to call the second list of accounts you give me my old records. I'm going to call the trigger operation you give me the trigger event. And then the other thing the method is going to do is it's going to tell us, what do you need to give back to me? So in this case, we have the word void, which is basically having our method tell us, hey, I'm not giving anything back to you, just void, nothingness. If I wanted, I could say, or hey, Boolean, and now I'd have to return true or false. at the end, or some other Boolean value. So this would be our method telling us, hey, I'm going to give you something back at the end. And then here, like Paul mentioned, we have our switch statement, which works similar to the if else, but a little more elegant. So here we see the word switch. We're going to tell it what we're switching on. So in our case, our trigger event. And then we see the keyword when. And this is basically saying, hey, when our trigger event is after insert or after update, I'm going to print this out. And again, we also see this plus sign that we talked about when dealing with different things here. So in our formula, we talked about how the plus sign is going to concatenate strings together. So here we have a string, trigger event is, and this is going to be kind of some, I think it's just basically implicit casting, turning our trigger operation into a string that we're able to concatenate and then print out using system.debug.
Yeah, system.debug has a lot of flattening and implicit casting functionality built into it. I think if you pass objects even to it, it will turn them into a human readable structure, which is quite cool. Yeah. Not all languages do that.
If only everything could do that. Then we see basically all of our different whens. And then we see a when else. So if none of the previous condition were true, just like else. So if we didn't have the switch statement, we'd have to do something like this, where we said like, okay, if trigger event equals after insert, trigger event equals after insert, or trigger event equals after update. And then what this is doing here.
Are those variables, do those variables resolve to true? It feels like that's using a true false, because normally when you do a case structure, you're evaluating to compare to a certain string or a certain value.
It's possible we might need to have it be a string, yeah.
Okay.
Okay, and then we'd say else if, trigger even before insert, and so on. So, but already, like, this is a lot more code that we have to now read versus the switch statement, which is a lot more elegant. So if there's a lot of repetitive code in your if statement, switch is definitely a great use case to get around having to write all this instead.
Gotcha. Yeah, and different languages have it implemented different ways. So I think JavaScript has a different implementation of the switch structure, and instead of the word when, it's case. So if you're switching between LWC and Apex, you'll have to remember that the different structures have different formats and use them appropriately, but they functionally do the same thing: is test a condition when after insert, when before insert. Each time, if it hits one of those whens is true, then it executes the code within that when and exits the whole switch structure, and then starts working at the code after the close of the switch parentheses that Adam's cursor is on at now. If it doesn't hit any of those and it gets to the when else statement, that's what it'll do. Okay, if I didn't match any of the ones above, do that. Otherwise, if you didn't have a when else, it would go all the way through that statement and do nothing and just start going to the next statement. So it's some extra preparation that you have to, or at least other functionality that you can use inside of the switch structure to manage logic.
And I think since you mentioned some of the other languages use case, I think there's actually a case formula function that does the same thing, pretty much.
There's a what?
A case formula function in Salesforce formulas. Yeah, I think it pretty much has the same behavior, where you give it a condition and it'll and basically what you want it to do for that condition.
Yeah, I can't remember if it uses. Okay, that's right. I think each switch is, well, anyway, I'll have to go look that up. I haven't played with that in a while, but yes, you're right. I have used that about 2 or 3 years ago. Converted a big mess of if else into a case structure or switch structure. Different names.
One other thing we wanted to point out when dealing with code as well, or in classes, are something called constructors. And so this is one approach. If we want a method here, just a method called handle trigger on the account handler, and I can pass in parameters directly to my handle trigger method. So we see that here. We could also use what are called overloaded methods, where basically we have the same method name, but a different signature. So here I have a handle trigger method that takes in 3 parameters. And here I have a handle trigger method that takes 0 parameters. And so I can eventually call that as well. And the reason these are able to work the same way is because of another kind of special type of method called a constructor. And a constructor basically is the template for a new instance of that class. So my class is called account handler. I have a constructor that's going to look like this. It's going to say, hey, I have an account handler, and this is what an account handler is going to be. If you want to make a new account handler, you have to give me the same 3 parameters as my handle trigger method, and I'm going to store them in class variables. And so every new account handler you create, you're going to give me your own version of these 3 values, and I'm going to store them in that account handler's copy of these 3 variables. And then once we have an account handler, right, in this line 15 and 16 here, I could say, hey, I'm going to make a new account handler. I'm going to call it AH, and I'm going to pass in those same 3 variables. And now I can just call handle trigger on that account handler. And this is the 0 parameter handle trigger. But it's okay, it has 0 parameters because the account handler actually already has all the parameters we need. So we can still reference this.trigger event. We can still reference this.new records, this.old records. And it'll be just like we're referencing them in the same way as our other handle trigger method that we had to explicitly give the variables to. So another way to write code as well with some different use cases for one or the other.
Yep, no, that's great. Yeah, I've seen I've seen some people stumble thinking that you can pass one object to a method or one parameter to a method that needs 3 and expect it to work, and it won't. If a function is defined with 3 parameters and the parameters of this type, you need to pass them 3 parameters of those types, or it won't work or do what it's supposed to do. The code behind the scenes is expecting those 3 things, and it won't let you call it. It won't let you invoke it with the wrong number of parameters.
Yeah, you can think of a method kind of like a contract. Like when you write this method, you're promising the method, hey, I'm going to give you these 3 things, or I'm not going to give you anything. And you can pick which one you want to use. But like Paul said, you can't say, I'm only going to give you 1 thing, because Apex is going to say, well, you have to give me either 3 things, you have to give me 0 things. 1 thing is not really an option that you've accounted for here.
And you could create another method with the same exact name, but the signature, and I don't agree really with the use of that term, but the signature is name plus number and type of parameters. That's what makes it unique. So if it's a different signature, it's a different method, and you're talking to different code. If you pass different variables, even if the method name is the same, can you have the same functionality but have the different function, or have a similar functionality but execute different functions in different code based on aligning with its signature and what arguments you pass it. All right.
Yeah, only other thing we have here, yeah, again, we see the equals to assign a value. I don't think we're using the double equals here, but it's kind of implicit here. So I could say if trigger is insert equals true.
Yep.
And that means the same thing as not having the equals true. It's implied for Boolean values. But again, here we see the double equal sign versus the single equal sign we saw before.
Yep. That's a good one. That's a good tip. I love that. All right, let me hop back to our slides. So I think we've covered everything here. Any other fun stuff? Let's see. Oh, functions. So we're talking about functions and methods. Something new in the Salesforce ecosystem called Salesforce functions is an entirely different thing. So I think we talked about built-in functions. So you talked about a built-in function for case, or could be a function converting something to text inside of a formula is technically a function. You showed custom functions with maybe we could, the interchangeable term of methods. Those are, Apex custom built functions, which are different than the intrinsic functions to the and operators inside of the language. Salesforce functions have to do with an abstraction layer where you can set up code inside of a containerized compute element outside of your Salesforce org and send processing load out to that and have the results be brought back into Salesforce, if at all. But that's a new thing that's being branded as Salesforce functions. It's not really similar to the functions we're talking about here. It's a bigger concept and more of an architectural component than it is of a code component.
Yeah, you might hear us use functions and methods interchangeably because different languages call them different things.
Yeah, there's a subtle definition around
Apex.
What's that?
Yeah, I was going to say almost always we're going to be talking about Apex.
Yeah,
when we talk about methods and functions.
Yep, as we go through the rest of these. So anyway, hope you get familiar, hop on these things, ask questions if you don't understand. This is all of the topics that we were going to go for this session. I think we went a little longer than we planned, but a lot of information presented there. Again, you should be fluent. Adam and I think except for constructors and the ternary version of if else, I'm very fluent in. Some stuff I have to go back and look up and do refreshers, but otherwise I've got a good natural, I understand the definition. I'm ready to interact with the concept when I sit down and write code. If you're not, keep studying, try it on your org, and ask questions and make sure you understand it. Write simple code, test it, and share it with friends.
Yeah, the one other thing I'd add is, and people who don't do development on a regular basis sometimes don't know this, unless you're studying for an exam, you don't really have to memorize any of this. You can always look it up. I myself have to look up, all right, how do I write a trigger, right? But if you can understand what code is doing and you can do a good search, you can definitely undergo the process of writing code, even if you don't remember off the top of your head, all right, here's how to make a constructor, here's how to make a ternary operation.
Very good.
Here's how to make a trigger even.
Yeah, no, I'm familiar with the concepts. I didn't understand what Adam was doing or maybe I think there was another way to type it. I would go Google some of the code, find out, reorient myself. Even inside of Salesforce, much less working in multiple languages across multiple integrations, which is a fun job to have, but it can make it a little disorienting. And when you're ready to sit down and write code, and you have to go, I just need to go Google some basics. I'm going to go look some of this up. Be familiar with the concepts. You don't have to memorize, just understand the stuff is going on. Yeah, a great point. Yeah, for the exam and certs, yeah. You're going to want to be firmly framed inside of it. If you're going to go take PD1, you need to speak exactly Apex and not get it confused with JavaScript and any of those kind of challenges. But just to be a good developer, understand the concept.
Yeah, and a quick thank you to Peter Chittum for the blog post that we took the switch case code from.
Yeah, Peter's always posting good stuff. Our next session we're going to tackle is SQL or SOCL. SQL and SOCL, another language that you use inside of Apex and LWC and Aura and Dev Console. But it's a pseudo language built inside of Salesforce. SOCL relates to its parent pseudo language of SQL, which is a structured query language. And then what is it? Salesforce is it's the S doesn't stand for structured.
Salesforce object query language.
Is it structured object or standard object query language?
I thought it was Salesforce object query.
There you go, Salesforce object query language. Thank you. I knew it wasn't structured. And that is used to get data in and out of the Salesforce objects and databases. So we talked about objects and relationships and some basic code structures. And then now the next session we'll be talking about how to grab objects and data out of Salesforce to use in your code. That is all. Adam, anything else to add?
Not much. Again, if there's something you don't understand, feel free to go back and watch the video again. Feel free to look it up. Feel free to reach out to us. Happy to take feedback and anything else we can do to help you get learning.
Yeah, I think Apex Hours has offered to host this video. I will upload it to YouTube. We will either get it or we may reconvene and give this again on Apex Hours. depending on how they want to do that. So that'll be there, and you can reach out to either of us, and I'll put our contact information there if you've got questions about where to go to learn more stuff. Adam Oshansky, thank you very much, sir, for joining me and doing this. I'm hoping this. I wish I had seen one of these when I was getting started, so I am very happy that we're able to put this together for people.
Yeah, my pleasure, Paul. Thanks for having me.